Good afternoon, folks. We just got through our first big day of stats. I want to do a quick summary for those who need a little extra help or maybe weren't here. So let's go ahead and share that screen so we can take a look. Okay, so here's what we did today. We talked about categorical data, and just so we can remind ourselves, categorical data is one of the types of data we're going to deal with. The other type we're going to deal with is quantitative. Okay, quantitative data has a lot of numbers. Categorical is categories. Like your hair color is a categorical variable. The grade, maybe your year at school is, so like senior, junior. Quantitative are numbers, so like your age, your height, your weight, that kind of stuff. A big thing to remember about quantitative is it's things that make sense to average. Makes sense to average. Okay, so what I mean is, if you think about it, your zip code is a number. It's numbers. 22309 is my zip code. But it would make absolutely no sense whatsoever to ever average those. Your student ID number is another number. But it would make no sense for me to average your student ID numbers or give you no value. So what I want you to do is ask yourself, does it make sense to average it? That's our categorical and our quantitative. We're really going to focus on categorical today. And there were three types of charts or graphs we talked about. There was a bar graph, there was a segmented bar graph, and then there was a mosaic plot. And we'll talk about all of those in various detail. There's one other one that we'll talk about later. We talked about in class. This is what it's called. It's called an ogive. We'll worry about that later. But the three I'll talk about today are bar, segmented bar, and mosaic plot. Okay, so this was a practice I actually asked you to work on in class. So I want you to look at a question like this. I'll go real quick on this. This is called a pictograph. So pictograph. Honestly, pictographs, they're just bad. They're just bad. I would just not do pictographs at all. Here's the reason why. If you take a look at this, the scale of this is from 44.5 to 49.5. That's 5 percentages, okay? And if you look at, there's a 5 percentage. This is 49. This is 46. If you look at this, there's a 3% difference between Xbox 60 and PS3. This does not look like 3%. This looks like significantly more. This is like 4 times the size. So pictographs are just bad. It's oftentimes a multiple choice question, so I wouldn't sweat that one too much. Okay, let's get down to the bottom. The bottom of this one is where we get into what are called two-way tables. We talked about this in class. It's a two-way table. So what I'm going to do is we're going to do a little bit of an analysis of this two-way table. We're going to read it. We're going to kind of see what we have here. So in this case, the Journal of American Medical Association, they did a study on depression, St. John wort, Zoloft, and placebo. So what I would want to do here is this two-way table. It gives me the change in depression as one, the treatment is another. This is called a two-way table. Okay. And what you want to do with the two-way table, if it's not already given, I would always recommend you do the following. Put in totals. So what I want to do is I want to total the rows, I want to total the columns, and I want to total overall. So there are 338 people in this table. But what I want to do is I want to do 27 and 27 is 54. 54 and 37 is 91. 16 and 26 is 42. 42 and 13 is 55. 70 and 56 is 126, 186, 192. And now I want to go down here. So 27 and 16 is 43. 43 and 70 is 113. 27 and 26 is 53. 53 and 56 is 109. 37 and 13 is 50. 50 and 66 is 116. And just so you know, if I added up 91, 55, and 192, I should end up with 338. If I added up 113, 109, and 116, I should also end up with 338. So now the question says, what proportion of subjects in study were randomly assigned to take St. John's wort? Okay, so in this case, St. John's wort, there were 113 people out of 338. So in this case, this is St. John's wort. You don't really need to reduce this fraction. Occasionally, what will happen is you'll look on a multiple choice and it'll actually ask you for the answer. So it's like about a third of the people who took St. John's wort. Why this value makes sense. subjects were randomly assigned to receive 1 of 3 treatments. So what they did is, if you kind of look at this, it's roughly a third. It's not perfectly a third. It doesn't have to be. It's just close enough is good. Now, what we talk about is we want to find the distribution of the change in depression from the subject in the study using relative frequencies. So again, if we want to look at it, there's 2 ways we can look at it. We can look at, this one's talking about, this is talking about the change in depression. So in this case, one of the changes in depression is full response. So in this case, what we'll look at is in terms of full response. Full response, his change was 91 out of 338, or about 27%, 26.9. Partial response was 55 out of 338. And that was about 16%, 0.163. And then no response would be 192 out of 338. And that would be what, 56.8%. So in other words, what this says is that honestly, in this study, more than half of the people had no response to it. So does this really tell us anything? Maybe, maybe not. You could also, when we talked about this in class, look at the analysis from the perspective of which one worked the best. So if I wanted to, I could check the treatments and I could say, well, St. John's wort showed full response 27 out of 113. Zoloft showed full response 27 out of 109. And the placebo showed full response 37 out of 116. Well, if you kind of look at this, placebo actually ended up with the greatest percentage of full response. So, you know, what I might infer from this is that this stuff doesn't work very well. The next one, what percent of subjects took Zoloft and showed full response? So, and is always digging into the table. So we're going to go to Zoloft, full response. That's those 27 people out of the 338 total, which means I think it's like 0.079, like about 8%. So in this case, that would be reading that table. And have you read in the table, if this thing had been an or, if I'd asked for Zoloft or full response, Zoloft is 109, full response is 91, 109 plus 91 gives me 200. But if you look, we double count that 27 because they're in the Zoloft row or column and they're in the full response row. So I'd have to subtract that 27 and double count it. So it'd be 173 out of 338. That would be an or. We'll get to that later. I just want to kind of give you a sneak peek. So that was kind of like our 2-way table. The backside, this is what's called the Mosaic plot. What ends up happening when we deal with a Mosaic plot is we are dealing with segmented bars. These are segmented bars because if you look at this, this is our juniors. So this basically is these 14, these 22, and this 15. So if you think about that, if we look at that, that's what, 36 and 51, that's 70 and 80. So that's our total number of people who are juniors, total number of people who are seniors, 44, 62, 25. So there are 131 total people. So what ends up happening is a segmented bar would have the scale run from 0 to 100%. But what would happen is these 2 bars would be equal in weight. So what would happen is, just imagine these 2 bars were literally the same weight. So it would show you this. So in reality, if you kind of think about it, it would almost be, let me kind of fold it so you can see what I mean. Kind of like that. So in a segmented bar world, you'd have 2 separate bars. They would not be combined. They'd be separate bars, but they would look like that. And the thing that you run into with segmented bars is it's great to look at it, but it doesn't give you a sense of magnitude. What I mean by a sense of magnitude is this. When I go out and I expand this out, I can see that the seniors in this table have a much larger number than the juniors. So I want to just show you the kind of like how a Mosaic plot works. So if you really want to look at it, if I didn't have this table and I was just looking at this, I would say, oh, well, the largest number of people in the study were seniors who fall in this gray box. Well, that's true, because these 40 are these 40. And if I looked at these right here, I'd say, well, you know, this one right here is going to look pretty small to me. Of all of these boxes, this one looks like it has the smallest area. Well, that's the 10. So it gives you a sense of magnitude. Mosaic plots are a new thing. They were on the AP test last year. Next class, we're going to start off with a kind of a reminder. But a lot of the times on this one, we're just reading. So calculate the proportion of juniors that are currently working, not working, but have had a job and have never worked. So what we're doing is we're looking at juniors that are working. So it's out of this one. We're looking at the proportion of juniors that are currently working. 14 out of 51. That's working. The next one, not working but had a job. Not working, had a job. That's 22 out of 51. And never had a job. That's going to be 15 out of 51. And then it asked me to do the same thing for seniors. So working would be 30 out of 80. Not working but have a job would be 40 out of 50 or 40 out of 80. So about 50%. Never had a job would be 10 out of 80. So now if we want to take a look at this in terms of summaries, like how could I summarize something? If you look at this in part A, really the percentages don't tell the whole story. While it looks like, you know, a large number of juniors never had a job, never worked, but they've had, are not working, but they have a job. What I want to notice is right here of these 22 people, yeah, it's a large number, but honestly, when you compare this to all seniors, realistically, this size box is, you know, these two are much bigger. These are bigger areas. There's more people in these two boxes than there are in this box. So, you know, if I were to have randomly selected a senior and a junior, or if I were randomly selected a student and you told me that they were a junior, you know, I could probably draw a conclusion that most likely that they're not working, but they've had a job. So in terms of what you want to interpret here, there's a lot of right answers. This is one of those answers may vary. Answers may vary. Okay, so answers may vary. So to summarize, what we talked about today is we talked about what we're called a frequency table. And a frequency table are your raw counts. We talked about a relative frequency table. And that's turning those raw counts into percentages. So this would be a frequency table. If I made it 14 out of 51, this would now be a relative frequency table. So 22 out of 51, 15 out of 51, there's my relative frequency table. So I've turned them into percentages. And then we had a cumulative relative frequency table. And what that is a running total. So what that means is, you know, this 14 out of 51, the percentage of the 14 out of 51, then what I'm going to do is when I do a cumulative, I'm going to add the 22. So the cumulative, the running total is 36 out of 51 and then 51 out of 51. So it's a cumulative. We're going to come back around to this. This is really what builds our ogive curve, and we're going to spend some time on ogive curves. So hopefully that helps a little bit. Please use your the reflection to kind of give me some feedback if you have it. But realistically, that's where we did today.